Good morning, everyone. My name is Ian Porter, and welcome to today's ATA webinar, Retrofitting for Energy Efficiency. This is the third in our series of webinars that we've been holding for people to log on to and listen to experts talking about various aspects of sustainability in the home. These webinars, we think, are a great idea for continuing our mission of sharing practical knowledge about energy efficiency, about sustainable building, and about water conservation in the home. The online format is great. It allows easier access for people no matter where they are. And can I just say as an aside, it's been lovely seeing the discussion in the chat box on the bottom right-hand corner of the screen of the weather around Australia, which is, of course, the abiding topic that seems to grab us all. We'll be recording each of these webinars to form an archive for you to view later and for people who couldn't log on today to view later. And I'd like to thank very much our friends at Bank MECU who've been supporting the webinars and providing a lot of encouragement to us at the ATA. Today's webinar is slightly different to previous ones where we've only had one or two presenters. Today we have three presenters, Michael O'Connell, Gavin Webber and Peter Fraser, each of whom I'll introduce in a moment. Each of those gentlemen will speak for about 15 minutes, and then we'll have 15 minutes of time for questions and answers at the end. For those of you who've been in these webinars before, you know that the way to enter a question is to use the chat box in the bottom right-hand corner. If you could this time indicate which of the presenters you're particularly interested in hearing back from, that would be very helpful. I don't promise I can get to everyone's questions, but we'll do our best in the time we have available. So thank you. Without any further ado then, our first presenter is Michael O'Connell. Now Michael, who is about to appear, I believe, below me on the screen, Michael has over 25 years experience in the telecommunications, IT, construction and renewable energy industries. He's a long-time member and past president of the ATA and a good friend to us all. He's an active member of our international projects group and has visited East Timor several times as a volunteer installing solar power systems in remote communities and training local people. Michael runs a design and energy management consultancy business with a focus on sustainable development. He designed and built his own house using passive solar design principles, together, of course, with solar hot water and an integrated permaculture garden. So I'll hand over now to O'Connell.
Thanks, Ian. It's great to be here, and as you said, it's been good to see. It's been good to see all of the comments coming down on the bottom, and keep those comments coming in, and also questions towards the end of the seminar. Now, today is going to be a fairly brief overview. We only have around about 15 minutes. Brief overview of energy efficiency in a home, and I'm sure there'll be some more questions afterwards, and we can field some of those. But let's move on to the next slide. Now, here we go. I think that was right. So, energy efficiency. Why bother? Why indeed? Now, different people have different reasons, and you can see on the screen some of the more pressing ones. Of course, there's the immediate financial concerns. If you can save energy in your home and become more energy efficient, you're going to save money, and you can use that to do other things, obviously. Or you can also use that to back down on your hectic lifestyle and as they say, smell the roses. There's also large concerns today about global warming, about greenhouse gases, and there's also an often not mentioned component, which is just comfort. If you have comfort in your home, it makes life much more pleasant. So even forgetting about the money, forget about the external environment, your home is just way more comfortable when you actually do energy efficiency. So yeah, there are many reasons, and we'll get to those as we go through. Now, there's going to be a combination of slides. It may look like we're jumping backwards and forwards a little bit, but bear with me. It will all make sense at the end. So let's go on to the next slide. Now, what is greenhouse? One of the main drivers, of course, for the ATA is sustainable technology to improve the planet, or at least to reduce the harm that we're causing. And a lot of people get confused about what is greenhouse, what is greenhouse gas, and what are greenhouse gases, and what is the impact. Now, if it wasn't for the greenhouse effect, we wouldn't be here, because it's a natural part of the Earth's atmosphere. And what happens is the sunlight coming into the planet heats up the planet, and then the heat gets radiated back out. And when that's all in balance, it sits at a stable temperature. And that's what we have today. So you can see there sunlight coming in, the yellow arrows, purple arrows, blue or purple arrows is the heat radiating off. And there's a small component which then gets trapped or reflected back to the Earth and makes it a nice, comfy temperature for us. And this is how we've evolved. We've evolved in this temperature range. Now, if things change, and they change quickly, we could be in a little bit of trouble. So the enhanced greenhouse effect, what we're doing now is we're putting in, with fossil fuel burning, etc., putting in extra greenhouse gases into the atmosphere, which is trapping a bit more heat. Now, the impact of that is you still have to have an energy balance. In other words, all the energy coming in from the sun has to match all the energy leaving, or otherwise the temperature rises, and that's exactly what we're seeing now. The temperature's rising, and scientists predict that we could have a 1.4 to 5.8 temperature rise over the next 100 years, with potentially devastating effects on our societies and well-being. Now, so how do we avoid all this, and how do we make our lives more comfortable, and how do we ease the pain on our hip pocket? And one of the answers, of course, and one of the things you can do personally is energy efficiency in the home. So let's have a look at the Australian energy home use. And you can see in here that by far the largest two components are heating and cooling and water heating, and they account for about 60% of the total consumption in the house. You can see that cooking is relatively small, lighting is a reasonable component, and so is refrigeration. And more we see these other appliances. Now, I haven't broken those down because there's no good reliable data as yet that I'm being able to find. But there are things like televisions and stereos, home entertainment systems, just all the odds and sods, mobile phones, computers, all those sorts of things just add to that. But by far, heating and cooling and water heating are the main components. And there's also a fairly good slice of lighting and refrigeration, which we can do something about straight away. And so they're the aspects that we're going to talk about. So what can we do about those? Now, one of the interesting things, of course, before we get to that, the next slide will show it's very, very similar to the previous slide, but it shows the greenhouse gas components of those various things. Now we can see that heating and cooling is actually dropped a little bit, so is water heating, whereas lighting, refrigeration, and those other appliances have increased. So because the reason they've increased is because they're primarily using electricity, and most of the greenhouse gas consumption comes from the generation of electricity right around Australia, with the potential exception of Tasmania, which has got a lot of hydropower. So you can see that there's a disproportionate amount of greenhouse gas generation from, say, lighting and refrigeration, which were quite low before. And so that's why one of the reasons we're going to focus, again, on lighting and refrigeration, and we'll talk around the periphery of other appliances as well when we start to talk about phantom loads. Now, comfort zones. Most people are very surprised to find that we can actually cope with quite a wide range of temperatures, and most people are comfortable between 18 and 27 degrees. So the key is that 22 degrees, as some of the ads on TV have portrayed, 22 degrees is not the ideal temperature. The ideal temperature is somewhere between 18 and 27 degrees. Now, of course, some people will feel the temperature when it gets a bit warmer more than others, and some people feel it cold more than others, and that's to be expected. But by and large, anywhere between 18 and 27 degrees is comfortable for most people. So what you can do is, in summer, you can allow the temperature in your house to rise a little bit higher, and so keep it up around 24 to 27 degrees. Some people don't like it above 26, because every extra degree adds 10% of the cost of trying to keep your house cool. So if you have a house that actually gets to a certain temperature and you're running air conditioning, if you keep the air conditioning up a little bit higher, or at least the temperature's up a little bit higher, then you'll save a lot of money for no real discomfort. And conversely, in winter, the same thing applies. You can drop the temperature down, not try and heat your house up so high, and it will also save you quite a bit of money. Now, I had a friend who, in winter, would have a house so hot, up around 25 to 30 degrees, that as you walked into the house, you had to strip off down to your shorts and T-shirt, and it was just shockingly hot inside the house. And if you had the temerity to turn it down a little bit, she'd jump up and down and hurl abuse at you. But this same woman in summer would keep the house at 18 degrees because it was far too hot outside. So it depends on what people get used to and how they develop habits. And a lot of this is about habits, and one of the things that we will talk about on is there's a difference between habits, behaviour, and behaviour, so turning that's up, down, putting on a jumper when it gets a bit cold rather than turning the heater on. Their behaviours, their habits, turning lights off when you leave a room. The other thing is retrofits. So putting insulation in your ceiling, for instance, is a once-off retrofit. You don't have to think about it anymore. So there are two aspects to that. As somebody said, warm slippers, long trousers, and long sleeves. That goes a long, long way to making you more comfortable when it gets a little bit colder. So keeping your home cool. What are the key ways that you can keep your home cool? Obviously, closing windows and doors during the day to shut out the heat, controlling cross ventilation at night, in other words, allowing cool breezes to come in, and helping your home stay cool is designing for passive cooling, which we'll talk about in a few minutes, insulating, protecting your windows, and eliminating air leaks. And those, particularly eliminating air leaks, can play a big, big, big part. So as you can see there's quite a lot of heat that comes through windows, through ceilings, through walls, and even through the floor, but as we'll see in a minute. But if you have to look down the bottom there, you can see that air leaks contribute to 5 to 15%, and other studies have indicated it could be as high as 20%. So it makes sense to control some of those air leaks if you want to keep your house cool. And again, you'll be more comfortable when you do that. Now, what about keeping your house warm? Well, using effectively a correctly sized heater, creating zones. In other words, don't heat up the whole house. If you're sitting in the lounge room, why heat up the bedroom? So creating zones so that you can actually heat up just the parts of the house that you're in. Using thermostats and timers. How many people have gone to work and forgotten to turn the heater off, and come home to find the house is sitting at a beautiful 22 degrees, and the cat looks up in appreciation when you've walked in the door because you kept the house warm for it all day. So having timers on your heating systems and cooling systems can play a big part. In my house, because I've got restrictions in the number of zones that I can put on, I actually have a thermostat and timer which automatically drops the temperature down overnight, turns the house, automatically switches everything off at around about 8 o'clock in the morning when people are getting ready to work, and doesn't come back on until we get home from work. So if you do have an automatic system, make sure you use it because it'll make a big, big difference. Circulating hot air. Now, it sounds funny, circulating hot air to stay cool, but we can actually cool down quite effectively if we have a moving airstream over our bodies. So if you have a ceiling fan, turn a ceiling fan on and direct that air over your body. It causes a little bit of evaporation and helps keep you cooler. However, when you leave the room, turn the fan off, because the fan by itself doesn't actually cool down the room. It cools down your body because of the moving air. So when you leave the room, turn the fan off, otherwise you'll just be wasting heat. And of course, wearing more clothes to reduce heating needs. Gets cold, put a jumper on. It's pretty straightforward, and if you ask your parents and grandparents, that's exactly what they did, and they survived to tell the tale. And also to help warm up your house, designed for winter solar gain. Again, this is passive design, which we'll talk about in a moment. Insulate, protect your windows, and eliminate drafts. So the three key things that can keep your house cool in summer are the same three things that keep your house warm in winter, and that's insulation, protecting your windows, and eliminating drafts. So keeping the cold air out in this case. And you'll see that there's some really, really simple solutions for eliminating drafts. The key thing you want to do when you're eliminating drafts is you want to control the ventilation. So it's only controlling the ventilation when you want the ventilation, rather than when the wind outside decides you want the ventilation. So what kind of heating? We're coming up to the winter season now. So particularly in the southern states, it's going to be an issue. Not so much in the warmer states. Now, types of heater. There's small portable heaters, there's single room heaters, there's ducted, there's whole house, and each of them have their advantages and their disadvantages. But go with the ones that are going to do the job properly for you. So there's no point getting a whole house heater if you spend all of your time in the lounge room, for example. There's also no point in filling up your house with several small heaters and try to run them flat out to try to heat up your whole house. So it has to be the right size for the right job. And that's very important. Now, small single room or portable heaters can be excellent for just sitting quietly in the corner, just reading a book or watching a bit of TV. There's also gas, electric, reverse cycle air conditioning, and each of those again have their advantages and disadvantages. Now, of course, gas isn't available everywhere. Not everybody has access to mains pressure gas, and even if you do use LPG, it usually works out 2 to 3 times the price. There's also, again, greenhouse gas emissions associated with gas, which you can eliminate fairly simply with electric by using green power, which we'll talk about as well. Now, electric, there's fan, radiant, and oil column, and reverse cycle air conditioning. Now, reverse cycle air conditioning is actually quite a good decision quite a good system for heating up your home if you have electricity only. Because reverse cycle air conditioners can be 3 to 4 times as effective as normal radiant fan or oil column heaters to generate the heat because of the way they work. So when you're actually looking at, we'll talk about energy rating labels very soon, go and have a serious look at reverse cycle air conditioning for heating if you are restricted to electricity for your heating needs. Now again, look for star rating labels. Do the clever thing, shut the curtains when heating, shut the doors and only heat the rooms in use. And again, every degree that you raise the temperature adds 10% to the cost. So turn down the thermostat and put on a jumper. I met a guy who said he was a classic energy waster, that when it got a bit cold he turned the heater on, and then when he started getting hot he took his jumper off. So don't be sucked in by things like that. It's very, very easy to get into habits which are counterproductive, and going through and checking things will make a big difference. Now, the other part of heating, passive heating and cooling, which we spoke about a little bit earlier, is simply letting winter sun in and keeping summer sun out. Now, as we know, the sun rises in the east and sets in the west, and it does twice a year. The rest of the time, the sun moves around in the sky. So it changes position in the sky where it rises and sets, and also changes its position in the sky up or down, depending on what time of the year it is. So you can see there that the winter penetration of the sun when it's low in the sky can go in, which is a reason that eaves are so effective in houses, and it's a crying shame that builders have chosen to get rid of eaves mostly for cost purposes, but they've convinced people that they're not necessary and they don't look very attractive. But having eaves on your house can go a huge way to getting good passive heating and cooling. So providing access to the low winter sun and excluding the high summer sun can make your house very comfortable, or a lot more comfortable, and also allowing cooling breezes to come in. So having a house set up, or even if your house isn't ideal, opening the windows in various parts of the house to let a cooling breeze come through can make a huge difference. And as you can see in the diagram there, using deciduous trees that let in the winter sun but block out the summer sun is a huge advantage, as are things like vines or grapevines or something grown across the north side of your house. Now, the only problem with having trees and grapevines and things doing that, as we found out at the ATA workshop at the Ceres Environment Park, is that it doesn't always follow your heating and cooling needs. So it may not be perfect, but it's certainly a lot better, but you may find that you still need to put some external shading up, or hack back the vines in some cases to get good autumn and spring performance as well. So just be a little bit aware of that. And again, with all of these things, it's all about looking to see what works and what doesn't work in your individual situation. Now, insulation is one of the key things that will help make your house more comfortable. All materials in your house absorb and transmit heat through your house. Now, the trick is to actually slow down that heat transfer, or eliminate it if you can. So it's essential. You can see in that diagram again, these numbers are slightly different to the numbers we saw in previous slides, but they're in this similar ballpark. But the heat escapes in all sorts of ways. So apart from air leaks, insulation can help with most of those in reducing those. So just say you could reduce those by half, you're going to save your heating and cooling cost by 50%. Now, it's important with insulation to realise there's two kinds of insulation. The R value, by the way, is just its ability to resist the transfer of heat. Now, the two types of insulation are bulk insulation, which resists the transfer of heat, and it does that by trapping air. And air is an extraordinarily good insulator, provided it doesn't move around. So most of the insulation properties of bulk insulation, like fiberglass bats or cellulose fibre, is the air trapped inside the bats. Some people make the mistake of thinking, oh, well, I've got an R2.5 bat, I'll shove another R2.5 bat in there and squeeze the two together and I'll get an R5 bat. But it doesn't actually work that way, because what you're doing is you're squeezing out the part that does the insulation, which is the air. So you actually end up with a worse performance by shoving, compressing insulation down in there. The other kind of insulation is aluminium foil laminated onto paper or plastic. So it resists the radiant heat by reflecting most of it away, and it's also not very good at transmitting or radiating that heat away when it gets hot. And you can do an interesting little experiment, carefully of course. If you've ever noticed you've got a black cast iron cooking pot, you can feel the heat a long, long way away. So you don't have to get your hand very close at all. But you have to get your hand very, very close to a clothes iron, because it's got a shiny surface and it doesn't radiate the heat away. So the best sort of insulation is often composite insulation, which features the best of both types. Now, if you want to see an example of how effective good insulation can be, have a look at these thermal images of two houses, one with poor insulation and one with good insulation. And you can see straight away the blue colours are cold and the red colours and orange colours are poor. Now, you can see in here that in this, where are we? In this, can't find where I'm doing now. In this thing here, you can see around here, you can see a window here, and that window there you can see is radiating huge amounts of heat. But if you have a look around in a few other spots, you can also see all the studs, all the stud work here, stud work there. You can see the two floors, so you can see that that stud work is actually transmitting more heat than the areas around it. If you contrast that to the house on the outside, you can see around here that we've still got the window transmitting a lot of heat, but nowhere near as much as the other one over here.
If you want to take it out of the bag, I'll buy it.
Excellent, thanks for that, Anna.
Sorry.
And you can see around the rest of the house that it's very, very cold. And that's probably the most obvious example that I've ever seen of how well insulation can make a difference. So, insulation is paramount if you want to have an energy-efficient home. Now, what about the windows? We just saw in that previous slide that that those windows were radiating quite a lot of heat. Now, an unprotected window can cost you up to $200 or even more these days, because I think that $200 was back in the day when heating and cooling was just a little bit cooler, like 6 months ago, a little bit cheaper. Double glazing is a great thing for putting in the windows. The double glazing hasn't had a good history in Australia because in most places of Australia we've got a relatively mild environment. Plus we had really cheap energy prices, although they're slowly rising. So, but it's of all the things that I did in my house, one of the things that I regret not doing was putting in double glazing. Would have made a huge difference to my heating and cooling costs. What I have done in the house is put in heavy curtains and pelmets, which we'll talk about in a second, to help offset that problem. But double glazing, the initial cost is high, and a few years ago, double glazing was ridiculously high in Australia, but it's coming down to a better and more affordable levels now. But as I worked out in my house, if I had have had the extra expense in double glazing up front, I would have more than paid for it several times over in my heating and cooling bills over the last 17 years. So it's one, as I said, one of the few regrets. Now, if you don't have double glazing in your house, you can actually retrofit double glazing. There are a couple of different companies around. The cheapest and easiest is a product called Comfort Windows, and I have no association with the company. It's just one that I'm familiar with, and I describe it as industrial strength cling wrap. So it actually gets temporarily glued on and provides a gap between the windows, between the window glass and the plastic flow. The other thing you can do, and there are a lot of other alternatives around there as well for retrofitting double glazing, including some do-it-yourself stuff as well. Window coverings, close fit, heavy curtains installed with a box pelmet. And the reason that heavy curtains with a box pelmet work so well is because they do the same thing as double glazing. They trap a still layer of air in between the window and the room, and the air insulates the room exactly in the same way that bulk insulation does. So let's have a look at pelmets and how pelmets stop the chimney effect. You can see around here that right in there you've got cool air flowing down between the curtain and the warm room. Now, if you've ever stood even by a sunny window in winter and felt the cold air coming along your feet, you'll see that effect straight away. So you have the cold air coming down, the warm air hitting the window, cools down, drops to the ground, runs across your feet, goes back to get heated up again. The warm air comes in behind it and drops down again, and then the heat radiates out through the window. And that's exactly what you can see happening over there. Now, if you put this pelmet up the top here, what you're doing is you're preventing that cold air from flowing down behind the curtain, and now it flows down in front of the curtain and leaves a layer of still air in behind the window and the curtains. And that layer of still air provides insulation between the room and the outside. So you can actually see that the warm air will then just fall down beside, and you won't get that heat flowing out through the window anywhere near as much. Double glazing. If you're going to go double glazing, why does double glazing work? It works in exactly the same way. You see on the left there's a bit of detail about how double glazing is constructed. There's 2 sheets of glass. There's a sealed airspace in between. There's a spacer bar down the bottom, down here, and down along the bottom here to provide the spacing. And also there is some moisture-absorbent material, a bit like the silica gel you get in when you buy a pair of shoes or buy some electronic components. And again, what that does is it's the layer of air inside stops the heat travelling through the window. So you can see on the right-hand side there that the heat stays inside or stays outside, depending whether it's winter or summer. Let's keep going because we think we're running a little bit behind, and I'll spend a little bit too much time explaining some of these slides. The other important thing, the other important thing is sealing out drafts. Now you can see in this diagram there are opportunities for drafts just about everywhere. I actually had an energy efficiency rating for a woman who had drafts everywhere. She was understandably upset when she had a $1,500 electricity bill, and she had a carpet on the ground that she called the magic carpet in front of the TV, because every time it got windy, the carpet lifted and floated off the floor. So there are plenty of opportunities, and there were plenty of opportunities in her house, and we saved her probably $3,000 a year just by cleaning up some of the gaps and cracks very, very cheaply. How can you clean up gaps and cracks? There are some really, really simple ways. One of the best ways, of course, is the old door snake down behind the door. Ask your grandma, she probably had one. Weather seals on this one here, corking up windows, and there's examples of some of the weather stripping and corking compounds there, and sealing fans. Now there are plenty of other things like sealing off your fireplace if you have a fireplace. Closing up the vents that are in the top of old houses. If you've got an old house, especially timber or an old weatherboard or brick veneer house with the vents in the top of the near the ceiling, they are just decorative holes in the wall to stop you suffocating when you're using kerosene heaters. You can actually close a lot of those up, provided you don't use unflued heaters. And the final one, we're running completely out of time, but lighting solutions. We're all familiar with old incandescent LEDs. We're also familiar with new fluorescents, which are a much better solution. And LEDs are coming up. Now, if you want to get a lot of good information about LEDs, see the current issue of Renew magazine, issue 119, and it has a complete breakdown and a buyer's guide for LEDs, and there's lots and lots of information in there with LEDs. One of the big reasons that they're becoming so popular is because they're so versatile. They're actually cheaper to run than compact fluorescents. And as you'll see in the next slide, cost comparison running a CFL versus an incandescent, you can see massive, massive savings with today's electricity prices. I expect LEDs to come down to about here or maybe even here in terms of overall cost very, very soon. And with much better options for replacing a lot of different things. So LEDs are definitely the way to go. But if you're not ready for LEDs, certainly use CFLs. Okay, I've been told I've got to stop. I've gone way over time, so I'll have to leave it there, I guess. And standby costs everybody knows about. We'll probably make a slide pack available a little bit later on. We'll just have to talk to a few other people. I'm sorry I've gone so much over time, but I'll stop it there and let Ian have the floor back again. Thanks very much.
Thank you very much, Michael. That's fantastic. And while we have gone a little over time, it's always worth it because it's such a thorough coverage of the issues that emerge in living sustainably in a home. As Michael says, we'll make the slide pack available later, and there's plenty of room for questions, although I notice we've had quite a good discussion going along between a number of our 105 participants at the moment. So thanks very much, Michael.
Thank you.
Let's move on now to our second presenter, Gavin Webber. Gavin's an IT professional and father of 4 living in Melton in Melbourne's outer suburbs. In 2008, after watching Al Gore's marvellous inspirational documentary, An Inconvenient Truth, Gavin set about transforming his way of life and by going green in as many ways as possible. The changes that he put in place include taking a close look at improving the energy efficiency of his house, planting a productive fruit and veggie garden, installing solar panels, and switching to a hybrid car. And marvellously for us, he's documented all of this in his prolific blog, The Greening of Gavin, which recently won our Renew magazine Sustainability Blog of the Year competition. I'll hand over to you now, Gavin. Just a quick note to the other presenters. There's a little bit of whispering noise or a little bit of noise, so can you all just check that you're muted while Gavin is presenting? Welcome, Gavin.
Thank you, Ian. Michael's presentation was fantastic, and I've got some pictures of some of the things that I've done around my home. So we had a hallway in the middle of the house that had no natural lighting whatsoever, and basically I thought, well, instead of using the lights during the day, because we actually had to traverse up this hallway, we fitted a solar tube, and as you can see, the before and after results are quite amazing. I was impressed with the way that, all the natural light, this is the north coming through the window here, as you can see through there, and, the natural light tube there that came through, that's fitted up through the ceiling up to the roof, and that's all weatherproofed. And, the solar tubes are quite good. There's some amazing sort of fittings. You can get like a crystal type filter or a plain filter. We just opted for the plain one. And you can see that the hallway is lit up quite well. They're not the cheapest of things. They're a little bit above $500 with fitting, but they negate the need for artificial lighting, as you can see. So quite a good product, and we were very amazed with the effectiveness of it. Even on a full moon lit night, the hallway is lit up. So it's quite amazing. So the next one, I've got some examples. Michael was talking about a window insulation. So we've got a couple of examples here. We've got some plantation shutters around the home, and they totally enclose the window, and there's a pocket of air there, so very good insulation for a window. We've also got some verticals which we haven't been able to replace yet because we're still saving up money. So what I've done is just over the top of the pelmet, just over this here, I've actually fitted a piece of thick cardboard and sticky taped it down. So that actually stops the airflow behind. So when we did get them replaced, and here's an example here on the right, this is actually a proper boxed-in pelmet, so that stops the airflow going through as well. So the next efficiency measure we took at our place was to retrofit solar hot water. Now, we had an existing gas hot water service, and it was working fine. It was a 6-star gas-rated solar hot water service, 300 litres, and basically I didn't want to get rid of that because, we'd already had the capital investment for it. So what we did, we basically bolted on a solar hot water service. This one was one that Origin Energy were offering for $2,100 back in 2007. It's probably a bit more now. And it simply takes the, I'll just some example, just down here, this is the cold water feed in here. And instead of going into the gas hot water service, it actually goes into this tank here. And so this preheats the water up to the panel there, and then returns, and the actual hot water return, there's a bit of a pipe here, you can't see it too well, but that goes into the gas hot water service. So we actually turn the gas hot water service off over summer, so that's quite amazing. And so for about 8 months of the year, we don't need the gas hot water service boosted at all. The water temperature comes out. Once it goes below about 45 degrees, I turn the gas back on again, and for the winter, but it's still boosting during the summer. So during the sunlight hours. So it works quite well. So that's an example of retrofitting a solar hot water service onto your existing gas or electric. Certainly cuts the bills down. Our savings for natural gas have been in the line of about 75% just by installing this. So other things around energy efficiency, we monitor our stuff here. I just do basic readings off of the meter, and I graph it in Excel. To look for abnormal energy spikes, I basically use energy as a PowerMate, which I actually purchased from the ATA, and it's a really good tool that you can sit there and measure an appliance for a 24-hour period, and you can actually tell roughly and basically how many kilowatt hours it would use over the period of a year. So then you can, if that thing breaks, then you can replace it with more energy efficient. So yeah, you can't actually measure any. If you can't measure something, then you don't know how to make the savings. That's basically what I'm trying to say there. Some of the other things we do around the home are turn off appliances when not in use. So, like for instance, the computer I'm talking on now, we turn that off at night. We've got a power board, all the peripherals are connected to it, and we simply turn it off. Same as our entertainment unit. When we do watch television, we simply turn off all the appliances all in one hit. And for those people who have the PowerPoint stuck behind, they're actually units like this one here that you actually have a remote switch that you can plug the power board into. So there are pedestal switches for your feet as well, and they work very well. So one of the things we do when something actually breaks, so when an appliance breaks, we try and do without it for a few weeks, other than the refrigerator. And we've done that for just about every appliance that's broken recently. So we think of other ways that we could probably do the task without using the energy. So after the few weeks of waiting, we make a conscious decision, which is a good thing to do, and see if we can get along fine without it. And one example I've got here is the dryer. This is our laundry. We don't have a clothes dryer anymore. So when it broke, we did without it for a few weeks, and my wife and I made a decision we could probably do without it. So what we did, we got a rack fitted in the laundry, and that actually helps dry the clothes from the hot air up in the upper part of the room. We also have clothes airers and stuff that we can put outside or use the clothesline, just normal old Hills hoist, and that works fine. In winter, we put the airing racks in front of the sunny north-facing windows, and they warm dry the clothes, no problems at all. So when you're in the market for a new appliance, if you do make that conscious decision, there's a few things you can do. You can look for the highest Energy Star rating, which indicates you can get an indication of the lowest kilowatt hour utilisation over a year. You can look for needs, not wants. You really got to think about whether you need these appliances or not. Sometimes the smaller ones are better than those big, massive American-style refrigerators. You can get a smaller one that suits your needs if there's only a few people living in the house. Choice Magazine, good place to go and have a look, and you can tell whether they compare the models for the best energy efficiency, and they also check out all the features as well. Also, you can go to energyrating.gov.au. That also has the energy rating of all appliances on the Australian market, and you can compare them. And also look for a long warranty because it may be an indication of a better product. And that's all I had time for. I'm not sure if I'm running out of time.
It's Ian, Gavin. You can go on for another 5 minutes or so.
Okay. I'll run out of slides, Ian, so I'm not sure if you want to cut over the next presenter.
In that case, fine. Thank you very, very much, Gavin. That's excellent.
Thank you.
And I thought a very nice contrast between yours and my presentations, and a lovely story about Gavin's, and I recommend, by the way, folks, that you have a look at his blog, is just that issue about change and learning and heading towards sustainability, which we're all doing at various speeds. Just before I introduce Peter, colleagues, can I just say we will run till about 10 past 12 or so there will still be time for questions. I apologise to anyone who has a pressing appointment at noon, but we can go for a little bit longer, which is great, and thanks to our conference hosts for that. So can I just move on then and introduce Peter Fraser. Peter and his partner moved from Sydney to Goulburn 3 years ago. Their house was built in 1924 and was very drafty, with no insulation and a delightful, no doubt, fibro lean-to at the back. Since then, they've built a solar extension and undertaken a variety of retrofitting tasks to make the house warmer in winter and use far less energy to run. They've also found themselves educating local builders and suppliers, and I think many of us would have stories along those lines, on sustainable design and products. And they're now part of an active local group going to encourage other residents to build and renovate sustainably and to raise awareness of green issues with local council and media. Welcome, Peter.
Thanks very much, Ian. Can you hear me? That's the first thing.
Yes, I can.
Great, okay. Great, thanks very much for that, and it's been a real privilege involved. We moved here 3.5 years ago from Sydney. It's a 1924 house. It had been rented for the last probably 10 years, and we were amazed when we went in to find that there was absolutely no insulation at all, and it was a very cold house. There'd been nothing done at all to make the place in any way efficient in terms of heating. So the people there were actually freezing cold, living in very cold conditions, and it was a pretty miserable place. So we set about, at the back of the house there was a lean-to, which we found actually you couldn't live in at all. We couldn't use this place at all for any kind of accommodation because it was freezing in winter and it was very hot in summer. It just had a tin roof and fibro walls. It was north-facing, and it was a great place to do something with because of the north-facing backyard. The soil was very poor, and you can see there the backyard was just a bit of rough old grass growing on a rocky soil. The thing about it is, and that was the north-facing backyard. You can see there how there was just nothing there in terms of the garden, and so we set about looking at how we could fix the soil up and start growing food there. But we really wanted to take advantage of the north-facing aspect. The place had a lot of really nice old windows, original windows. These are wooden framed, coloured glass in the tops and bottoms. And we were trying to work out how we could insulate these windows to get some sort of double glazing in there. And we did quite a lot of research looking around to see what we could do in terms of double glazing. It also had really nice patterned pressed metal ceilings, but on top of the ceilings there was no insulation. There was just a lot of dirt that had accumulated over 70 or 80 years. So we started thinking about how we could do something about the roof as well. But in general terms, it was pretty cold when we started in our first winter. It was also incredibly drafty, and one of the things we realised is that they'd removed all the carpet and they hadn't done anything about blocking up the gap between the floorboards and the the skirting board. So we went and bought a whole lot of that sticky back sponge stuff and basically went around the whole house, filling up these fairly large gaps, some of them half an inch wide. They're all, this one here was facing west, and in the winter, Goulburn cops a fair bit of wind for 2 or 3 months, so it was getting very cold there. So we went about blocking up all these gaps with this sponge, basically. At the same time, we started investigating the double glazing of windows, and of course, here's a shot of the window gap that we put in this D-shaped rubber stuff, which stopped the wind getting through the windows, and that blocked out a lot of the draft as well. But then we started looking at how we would double glaze these windows. This is a shot from the inside. We're trying to work out what process by which we could cheaply double glaze the windows without wrecking them, because we didn't want to make any kind of alterations to the windows. So what we did was we found a company called Magnetite, and Magnetite have this 3mm thick plastic. I guess it's a perspex, and they put it in a frame, and then they stick it to your window. And that shot there is a picture of actual Magnetite double glazing that's been stuck onto those windows, and it's a removable pane that is easily pulled off to clean when you have to clean it. And the main thing about it is, from the inside, it doesn't damage the look of the windows. It has no effect on the look of the windows at all, and that's the picture of the front hall. And you can see there's a frame, if you can make it out on those windows there, that's got the perspex on it. Here's a shot of one of the windows with the frame on it. You can see the frame on the inside of the window sitting around there, but you can see that it doesn't actually have any impact on the visual sight through the window. And one of the other big benefits from it is it cuts down sound considerably. The street that we're in has a fair bit of traffic, and when we put this stuff on, it really reduced the amount of sound coming through into the room. This is the bedroom, and it cuts down on the sound. But it worked really well as a double glazing. It comes with these little rubber suction caps that you use to pull the frames off. And there's a shot of a frame that has been pulled off the window for cleaning. And it's just a very simple matter of just, putting the suction caps on and then just pulling it straight off. It's basically a plastic frame around the perspex, and here's a shot of the back of the frame, and it's just got a magnetic strip that's stuck onto the frame, and then onto the window, a metal strip is stuck onto the window, and when you put the frame onto the window, it just sticks on, and just a very simple sticking on kind of procedure that's easy to pull off. So it's a very simple system. It's pricey, but it's nowhere near as pricey as doing double glazing. If you want to maintain your windows and not wreck them, it does actually provide an alternative to cling wrap. It's permanent. We've had it there 3 years. It's easy to clean. We only clean it once a year, and it's a simple system. What we did at the back of the house is we put in a polished concrete slab, which was insulated with air cell underneath it. This is the north-facing part of the place. We put bladders underneath for water, so we've got a fair bit of rainwater that we harvest for the garden. And then this polished concrete floor takes the sunlight from the north and heats up during the day and keeps the place very warm. That's a shot of the part of the place half completed. It's a double brick house. We put in double glazed windows and doors, and these are plastic frames, so that we wanted to keep the place looking as much as we could like the original building, but we also wanted to use plastic as a window framing system, and then double glazing on all the windows. Then there's, of course, insulation in the roof, there's air cell in the roof, and there's bats in the roof, plus insulation between the gap and the two brick layers. And underneath this deck here, again, there's more bladders, and it's one of those composite timber plastic kind of product. From further back, you can see how we've got rid of the extension. We've put this new extension on. We've got a shading over an awning over the windows, which allows the sun in the winter, but keeps the sun out in the summer. And the sun comes in through those windows, hits the cement polished concrete floor, and keeps that room and the rest of the house reasonably warm. Then we put in a native garden and a permaculture vegetable garden on top of. It was a no-dig garden. We put it on top of the poor soil, and that's a shot of what we've been doing in the last this last summer that's gone by. We've produced a lot of vegetables. That's really about it. The result of it's been cut down on our heating bills by about 40%. We've put in solar voltaic cells, so we're actually now making money out of our electricity bill. But it's been a good exercise in trying to fix up a house which was freezing, and it's now quite well insulated, and we've cut down our bills considerably. That's about it.
Fantastic. Thank you very much, Peter. That's excellent, and some, I just think, two lovely stories to follow up from Michael's introductory presentation. Colleagues, what we will do now is ask the other presenters to unmute themselves and join us, and we'll take any further questions. Before we do that, I note that there's been some very active and at times very entertaining conversation in the message box, which I think is great and a very good way for these sort of webinars to work. The topics that have been covered in great detail have been things like refrigerators, life cycle costing thereon. We've had some discussions around the nature of the MEPS program, the Minimum Energy Performance Standards, how those are structured, how they work. We've had some good discussions around zoning and around clothing during Michael's comments early on about wearing warmer clothing at home. So I think it's been quite useful so far. While you're thinking about questions to put back up now to the presenters, one thing that I don't think was answered was the question around the solar tube or skylight sort of technology. Do you lose a lot of heat through that? So I guess either Gavin or Michael, if you can comment on that while people are starting to throw questions to us, that would be great.
Yeah, it's Gavin. No, I don't believe you do lose a lot of heat. It is actually sealed top and bottom, so there's no airflow through the tube itself. So the actual sealing part is sealed in, so it doesn't flap around on the breeze, so no heat loss there as far as I can tell. And the top part of the unit is weatherproof, so it would probably act like a curtain over a window, you know, with a box helmet.
Yeah, and all those products are the same. They you've got to look out for skylights. If they're sealed, and the better ones are, you don't have any real heat loss problems. You can, however, have some heat entry problems with the older style skylights. So in summer, it pays to have shades over those. But as long as they're sealed top and bottom, you're fine. Yeah, I noticed there's no heat gain because on a 38-degree day, I put my hand up to the solar tube and it's just as warm as the ceiling is. Yeah, solar tubes and similar technologies are very good for that, actually. Yeah. Yep.
And there's a few answers also floating down the message box. One of the at the end of this conversation, colleagues, is start a thread for further discussion of some of these issues on the ATA website. That's www.ata.org.au. We have a forum section where people are able to, without being ATA members, just enter into discussion on any topic they want. And there will be a thread set up shortly to follow up discussion at the end of this webinar. Okay, other questions? There's been a bit of discussion around feed-in tariffs. I don't know if anyone wants to comment on those, but it looks like a number of people have noted that state governments appear to be moving away from feed-in tariffs as a way of supporting solar PV. I don't know if we need to say much more about that. There are specific questions people had of a technical nature at this time. Our conversation has gone rather quiet. Colin?
Everyone's probably furiously typing. One thing I was going to mention towards the end of the thing was, and Gavin sort of mentioned it, or both presenters mentioned it, is that one of the ways they tracked the performance was not just the comfort of the house, but looking at their energy bills. And it seems like rather an obvious thing to do, but after you've done each little bit of retrofit, for example, it's a really good idea to just monitor your bills, and it's pretty easy with the graphs they have now. But using the kilowatt meter or another energy meter, or some of the other commercial ones that get fitted into your house, can make a huge difference. There's nothing better than immediate feedback to reinforce the changes and the benefits of the changes that you've made. So so keep an eye on your power bills and your water bills and your gas bills, but also if you can, go out and read the meter every day or every couple of days and get a much more accurate feedback on how it is that you're going.
Yeah, I tend to agree, Michael, because on my blog I did a challenge called the Great Kilowatt Challenge, and I challenged people for a month to read their meter every day, their electricity meter. We only did electricity. And people were starting to then get an idea of what their total house usage was per day, and when they turned something off, they could see the immediate effect, which is a great driver to spur you on to do some more energy efficiency measures. So people were making quite large reductions in their energy bill just in the course of a month. I think one of the best competitors was they went from I think they cut their power usage by about 60% just over the course of a month, just by checking every day.
It's amazing, isn't it? We've got a quest practical, is it, to add thermal timber floor. Any comments on what you can do there, Colin?
That's a hard one. It's thermal mass is difficult to retrofit. Well, it can be expensive. I mean, one way that just pops in my head, and I don't know how practical it is that would be to get in and pour in situ slabs in the floors, but that would of course mean pulling up the floorboards and going in that way. I'm not aware of any real easy way, unless you want to make your furniture out of concrete, but seems a bit pointless. So that's a big job doing that, unless you've got a good load-bearing wall that you can construct an internal brick wall or something like that. I did notice another question talking about underfloor insulation and what's the best way to do it.
Yep, I was just going to come to that one, Michael.
Yep. The two easiest ways are to either use foil, which is stapled onto the underside of the floor joists. These both rely on being able to get underneath the floorboards, by the way, and so if you've got no space under the floorboards, you've got no choice but to either put something over the top of the floorboards or put something underneath. Instead of putting something underneath. But there's also foil-backed foam boards that you can glue in place. The advantage with gluing those in place, they do two things. They prevent rodents from inhabiting the space between the foil and the boards. They provide the insulation properties, but they also stop any drafts. So if you do have any drafts coming up through your floors, it instantly stops all those drafts, so it's a double whammy. If you can't do that, carpet or some other floor covering will do the job.
Michael, another question for you from Martin. Are you able to comment on using double glazing when you're actually looking to increase your solar gain from your north windows? Yeah,
you are. In fact, but there's a danger with one of the things that people forget about with double glazing is double glazing works because it prevents the heat from travelling through the glasses easily. So, but it doesn't prevent the sunlight. So in summer, if you've got a double glazed area, the sunlight still comes in warm, trapped in the room and can't get out. What you can find is if you don't shade the windows in summer, what used to be an okay, comfortable room in summer before double glazing becomes unbearable in summer. It's beautiful in winter, but it becomes absolutely unbearable in summer because the sunlight gets in, heats up and can't get back out. And you only have to sit in a car on a freezing cold sunny winter's day to know how quickly a space with lots of glass can heat up. So it's critical that when you put in double glazing on a north-facing room that you also put in something to prevent the sunlight getting into the room, or put some sort of reflective curtain material on the inside that bounces the sunlight back out before it turns into heat.
Right. Other colleagues, Gavin, do you have any comment on it?
No, not really. We haven't been able to afford double glazing around our place, so we just use passive solar, and we've got canvas awnings on our north-facing windows. Will be pulled right down to the bottom of the window on a really hot day, and we find that the temperature in that room and the north part of the house stays at about 27 degrees, even when it's 38, 39 outside. So we managed to get away with that.
And again, I've used in the past. Originally, I just sticky taped aluminium foil literally onto the glass in the windows before I got around to putting proper coverings on. And even though it darkened the room, obviously, it made a huge difference. Dropped the temperature 5 degrees. But what I've also used is I've made up just hanging frames with foil-backed sisolation and just drape that in
Yes.
front of the windows, which works. Really cheap and simple double glazing. Cut it to size and hung it on a hook just so it's set inside the window frame. And and if you just want the light without the view, that works perfectly.
Yeah, I've used it back in winter, so it works really well.
Just a technical question came up. If the wattage of a reverse cycle air conditioner is the same as that of a column heater, how is it that they're better in terms of efficiency?
Because they work in the same way as a refrigerator, what they do is they're a heat pump, so they transfer heat from one side to another. So for every kilowatt of power that you're using in a normal electric heater, you get 1 kilowatt of heating. But for every kilowatt of power that you use to drive the compressors in an air conditioner, you not only get that kilowatt that you're using to drive the compressor, but it also pumps another 2, 3, or 4 kilowatts from outside inside. So you actually get a multiplier effect, and that's what that coefficient of performance or COP rating is about. So a COP rating of just an ordinary electric heater is 1, because 1 in, 1 out. But a COP rating of a good quality reverse cycle air conditioner for heating can be 3 or 4, so you get 3 or 4 times the benefit.
Excellent. A couple of people are asking about using air tubes to draw cool air from the ground into the house, obviously during summer.
That works quite well if you've got the right sort of house and if you've got the right sort of layout. On a standard house, it can actually be quite good, and a few people have done that. They've also done improved ventilation. I have a friend over in Yarra Valley who's built sort of partially into the side of a hill, and he draws the cool air up from underneath the house and does an amazing job. But for a lot of houses, the benefit is shooting out for a couple of days. The underneath of the house can slowly heat up, and you get less of a benefit. But it's still a good idea to circulate air in the house anyway, because it helps cool you down.
Excellent. Well, colleagues, I think we might now draw things to a close. Thank you very, very much to our 3 presenters today, to Michael, to Gavin, and to Peter. We will be posting online very shortly the presentations once we have them, once they're available. And I know a couple of people have been very much asking if we can possibly get Michael's presentation today. So we'll have a look at whether we can.
I was about a third to half of the way in the presentation. I didn't get the time quite right.
That's all right. I think people have learnt a lot today, which is great. I had a couple of minor comments just from an ATA perspective before I go on and finish the thank yous. This is a power switch which basically makes switching appliances off very easy. It's the sort of thing that a number of the presenters have touched on, and we have these in the ATA shop online if anyone's interested. Likewise, one of the other new products that we have online, and I apologise for the advertisement, colleagues, is the Valve Cozy, which one of our members has designed, invented, and made ready for sale, which sits over the external valve, the release valve on your hot water system, and can save about 7% of your water efficiency. And again, we have those in our ATA web shop, so just a small advertisement there. More detail on Gavin's prize-winning blog is available in the current issue of Renew magazine, available obviously from us at the ATA or in good newsagents. I should say again that our webinar is supported by our good friends at Bank MECU, who have a responsible investment, promotion of the community and involvement in sustainability initiatives, and thanks very much to them for their support. I noticed that we've now got a link posted in the message box to the ATA forums for those of you who wish to go there and continue this discussion. And thank you all for participating. We had over 100 participants. We've gone down to about 80 now in today's ATA webinar. To a very short survey. Your feedback would be fantastic, because we are looking to continuously improve these webinars and make them more useful. So if you could take a couple of moments to complete that, that would be fantastic. I see now Anna's posted, I think to presenters, could you post that to everyone, please, Anna, that we now have a forum thread ready for this conversation. So from my perspective, that wraps everything up. Thank you once again to our three presenters, and thank you to all of those who participated. And I hope you have a very enjoyable and very sustainable day.